Hello everyone. In this video, we are going to understand one of the most popular data structure and coding interview problem. To sum, we will first understand the exact requirement, then write a simple brute force solution in Swift. After that, we will analyze its time complexity and space complexity and understand when this approach may still be reasonable choice. In the next video, we will solve the same problem using other approaches and compare their trade-offs. Let's first understand the problem. We are given an array of integers and target value. We need to find out two different elements whose sum is equal to the target and then return their indices. For example, suppose our array is 2, 7, 11 and 15 and the target number is 9. Here 2 plus 7 is equal to 9. The number 2 is available at index 0 and the number 7 is available at index 1. So our expected result is 0 and 1. One important point is that we cannot use the same array element twice. For example, even if the target is 4, we cannot use number 2 twice unless two separate values are available in that array. Before selecting any data structure or algorithm, we should understand the exact requirement. We should ask questions such as, is the input array sorted or unsorted? Do we need to return the original indices or only the values? Is exactly one solution guaranteed? Can the input contains duplicate values? Can we modify or sort the original array? These details can change which solution is best. In this example, we will assume that the input is unsorted. We need to return the original indices. We cannot use the same element twice. And the input size is small enough that the brute force approach will not create a significant performance issue. These points are not strict rules. They are simply decision shortcuts that help us think about the problem before choosing a solution. The final choice can still change decision depending on the actual constraint such as input size, memory limit, whether the array is sorted, and what output we needed. Here I have shown some possible approaches to solve the two-sum problem. We do not choose one solution for every situation. Different use cases may require different approaches. For example, if the input is small, brute force may be acceptable. If the input is large and unsorted, the dictionary may be better choice. If the array is already sorted, the two-pointer approach may be more suitable. So, the purpose of this slide is to understand that the best solution depends on the problem constraints. So, let's begin with the most straightforward solution, brute force. The idea is simple. We select the first number and compare it with every number after it. Then we select the second number and compare it with every number after that. We can continue until we find a pair whose sum is equal to the target. Now let us look at the Swift program. The function accepts an integer array and a target value. It returns an optional integer array because it is possible that no matching pair exists. First, we check whether the array contains at least two elements. If it contains fewer than two elements, we cannot create a pair. So, we return nil. Next, we have two nested loops. The outer loop uses first index to select the first number and the inner loop starts from first index plus 1. This ensures that we do not use the same element twice. It also prevents us from checking same pair again in reverse order. For example, after checking 2 plus 7, we do not need to check 7 plus 2 again. Inside the loop, we add the two selected numbers. If their sum matches the target, we immediately return their indices. If no matching pair is found after checking all possible combination, then function returns nil. Now, let us analyze the time complexity. We have two nested loops. The outer loop can run approximately n times. For every outer loop iteration, the inner loop may also check many of the remaining elements. The total number of comparison grows approximately like n into n. Therefore, the worst case time complexity is O n square. For 4 element, this may not be a concern. But if the array contains thousands or millions of elements, the number of comparison can become very large. The function may sometimes find the answer during the first comparison, but complexity is normally discussed using the worst case unless interviewer asks for something different. Regarding space complexity, so it is O1. We are not creating another array, dictionary, set or collection that grows with the input. We only use a few index variables. The number of these variables remains the same, whether the input contains 10 elements or 1 million elements. Therefore, this solution uses constant additional space. The brute force approach may be acceptable when the input is guaranteed to be very small. It may also be useful when additional memory is extremely constrained because this solution uses only O1 extra space. It is also a good starting point during an interview. We can first explain the simplest correct solution and then discuss how to optimize it. However, brute force is generally not suitable when the input can become large, when the operation runs frequently, or when performance, CPU usage and battery usage matter. So our final complexity is time complexity O1 square, space complexity O1. This solution is simple and memory efficient, but it does not scale well. In the next video, we will solve the same problem using a dictionary. That solution will reduce the average time complexity from O1 square to O1, but it will use additional memory. We will also understand why that trade-off may be worthwhile. Thank you for watching.